Hi, my name is Zach J, and I am a tutor here at Chegg.com. Today, I am going to be talking to you about the fascinating topic of Newton's third law of motion. Okay, so Newton's third law of motion basically states that for every action, there is an equal but opposite reaction. And so, to explain this, we're going to meet my friend Dave. So this is Dave, and he weighs 75 kilograms. And so what our question is asking us here is how much force is the box putting on Dave? So Newton's third law states that for every action there's an opposite but equal reaction. So the action of Dave is to put a force on this box. And so that we will do, this is called a point diagram. And so we have a point here which represents Dave. And he is applying a force down on the box. Okay. Now the box, according to Newton's third law, is applying an equal force as this force, but in the opposite direction. Okay. So these two forces are equal, but in opposite directions. So we know that the force that Dave is putting on the box is equal to his mass times the acceleration of Earth, or 9.8 meters per second squared. And we also know from Newton's third law that the force Dave is equal to the force of the box that's pushing up on him. That's Newton's third law. So then we can use this to figure out how much force the box is putting on Dave, which is the same thing as saying how much force is Dave putting on the box, because they're both opposite and equal. So really all we have to do to figure out the force the box is putting on Dave is to calculate Dave's mass times his acceleration. So Dave's mass is equal to 75 kilograms. And the acceleration of Earth is 9.8 meters per second squared. And so if you do the math, the force the box is applying on Dave is approximately 750 newtons. Okay? So really, that's a pretty cool thing. You know, just from this one law, we know that each force is equal, and that we can calculate the force the box is applying to Dave to keep him from falling like through the earth. If the box didn't apply a opposite and equal force, he would just keep falling and like fall into the molten lava in the Earth's core, which would be very, very bad. We can't live there. So this law is incredibly important for that reason. We need this force in the opposite direction to keep us from falling through things. Okay? So let's have another example. And Dave has now built a rocket. He wants to go to the moon because he's crazy. No other reason. He just wants to go to the moon. And so the question here is asking, how can he get to the moon if there's nothing for the rocket to push on in space? Because space is a vacuum and there's no air. Okay? And, in the previous example, we had the box, which was Earth. And, there is something there within a tangible mass. Okay? In this example, though, it's a trick question because, rockets, we've propelled them to the moon before. And so the reason it's a trick question is that rockets have jet fuel and it has this propulsion system. So in this example, the rocket is accelerating this way towards the moon, and so it is pushing this way, right? But the jet propulsion fuel is actually pushing in the opposite direction. Okay? And so this gas that's being made by the rocket fuel allows the rocket to be propelled this way. Okay, so those equal but opposite forces allow us to get to the moon, which is pretty cool. One other question I have for you is if you have a school bus. So let's say here we have this school bus, okay, and it's traveling along at whatever speed, doesn't really matter. There's our bus, and we're traveling along, and then there's a bug, okay, and this bug flies into this windshield. So let's put this little bug here. So that's the little bug, and it flies into the windshield and gets smashed all over the windshield, okay. And now the question is, was the force of the bus or the bug greater? Okay, I'll let you think about that for a second. Okay, if you said the force of the bus was greater than the bug, you're wrong. Because for every action there's an equal but opposite reaction. So the force of the bug hitting the bus was equal to the force of the bus hitting the bug. They're equal and opposite. Okay, Newton's third law. And so the reason the bug gets smashed is because the mass of the bus is so much larger than the bug, and it just gets obliterated because of that. But the forces being applied are equal, and so for every action there's an opposite but equal reaction, and therefore the bug gets smashed, but the forces are equal. Okay, so I hope this kind of clarified Newton's third law of motion. It's pretty straightforward, but if you have any questions, please feel free to contact me on chegg.com/tutors or any of the other tutors. I hope you have a great rest of your day, and I hope to see you back here again. Goodbye.